Hi, my name is Nolan in the E&V 2120 class, and this is my presentation about coastal beach groin construction. Firstly, what is a coastal beach groin? Groin is defined by Cambridge Dictionary as a low wall built out from the coast into the sea to prevent the repeated movement of waves from removing parts of the land. Groins are built out of a simple need to slow down the ever-shifting nature of a beach. Beaches are dynamic systems and are constantly responding to the natural processes around them, such as erosion, deposition, and longshore drift. These processes all transport material in and out of beaches, making them change over time. A groin is a structure built perpendicularly out from the coast that is designed to halt the natural longshore movement of sediment in beaches. Groins act as a physical barrier to bedload transport, effectively halting it and allowing the sediment to build on the updrift or supply side of the beach. This also shifts the beach orientation to reorient towards dominant wave directions. A caveat to this is that any beach sections on the downdrift side from the groin will receive a reduced amount of sediment and therefore reduce in size and be more exposed to erosion. This is also why groins are often found in a group or field. It reduces this effect and more efficiently builds up a beach over a larger area. Downdrift areas, however, will still require regular nourishment and upkeep to reduce downdrift erosion and keep sediment buildup consistent. The effectiveness of a groin depends on several variables. Firstly is the area of littoral drift that is covered by the groin. Longer and higher groins may be better for areas with more oblique longshore drift. However, one does not want the entire area of sediment to be covered to allow some sediment to reach the leeway side of the groin and build up on the downward drift side. Secondly is the material the groin is built of. Most groins are built of rock, timber, or gabions, with rock being the most common. Rock is a cheap material for construction with good durability and helps absorb wave energy. Timber and gabion groins, in contrast, last much shorter and tend to reflect wave energy rather than absorb. Concrete, steel, and other more expensive materials are also commonly used. Finally, one must be aware of the angle of wave incidence and amounts of littoral drift in your coastal system. Groins are optimal near perpendicular wave incidence and a small to moderate amount of littoral drift. Groins used in areas of very oblique waves with a large amount of sediment movement are usually not worth it, as the sand accretion is very temporary in these stormy areas as the high amount of erosion, and sediment buildup can also be excessive, having negative effects on the marine environment. A real-world example of groin deployment is Port Richards Bay, South Africa. This location reportedly experienced coastal erosion along its southwestern shoreline, which had the potential to destroy local infrastructure such as an important roadway. It was determined that the area had relatively small current velocities from wind, wave action, and flood action, with a large angle of wave incidence as well. 4 rock groins were then constructed along the coast. In this case, the results showed a positive accretion and stabilization of the shoreline. Groins A and C, pictured here, saw a rates of accumulation varying between 0.025 and 0.065 meters per day. Shoreline erosion did occur behind groin A, but this is to be expected and helps with shoreline stabilization. Equilibrium between the two groins is expected to be met within 3 to 4 years after the project. This example shows the positive effect of correctly using groins. The area was very well researched beforehand, and collaborations were made with local community to effectively implement each of the groins. To conclude, groins are an effective way of slowing gradual longshore drift in beaches, but it is necessary to undertake extensive research to effectively employ groins in the coastal area. Furthermore, groins must be maintained and nourished to ensure they remain effective and do not significantly degrade their downdrift areas.